Real numbers. All right, so here's a diagram of the number system, the real number system. Okay, you have real numbers, which encompasses everything. Everything, all our other numbers fit inside real numbers. Okay, and then we have two different splits. Okay, so real numbers is any irrational numbers, any rational numbers, anything that's inside it. Okay, we have two different categories inside of real numbers. The first one is irrational numbers, and those are numbers that can only be written as a decimal that goes on forever and doesn't repeat. Okay, so the one you're most familiar with, the one we use the most, is going to be pi. Okay, so pi is your most common irrational number. Most of the other ones you're going to look at, those are going to be things like the square root of a non-squared number. Okay, we'll look more at square roots later on, but most square roots are going to be irrational numbers. Not all, but most of them. Okay, a rational number is kind of the opposite of an irrational number. A rational number is any number that can be expressed as a fraction or as a decimal that terminates or repeats. Okay, so this could be these nice, easy whole numbers. Okay, something without a decimal, that's still a rational number. And you can see that all these numbers are inside of our rational numbers category. But it's also going to be things like maybe I'll change color, 0.32512, and it ends there. Okay, that's going to be a rational number, or 0.33 repeating. Okay, or just 0.3 repeating, because it's the same thing. That's going to be a rational number. It repeats forever, or it ends. Right? An integer, you can see here, that's kind of our first step inside of rational numbers. Those are all those numbers that don't have any decimal on them. Okay, it's going to be, all your negatives, all your positives, 0. As long as it doesn't have a decimal on it, it's going to be an integer. Okay, going one step further in, whole numbers, that gets rid of all your negative numbers, but we still have 0. And then the natural numbers are all those whole numbers, but we don't include 0. Okay, these are also called the counting numbers, the natural numbers, because they're the ones that make the most sense in the real world. Right? We use those all the time. It makes the most sense. How many apples do I have? Well, I've got 3 apples. Okay, it's natural. All right. The last category that we won't look at too much is called imaginary or not real numbers. Okay, and this is something that's been created. Mathematicians thought this up. They were like, oh man, I need something, I'm trying to solve this really complex mathematical problem. I need something to fit in here because nothing we have does. And so they made up a number. Okay, we're not really going to use these, and you're not going to use them unless you go on, but we need to know that they exist. We need to know that there are some numbers that aren't real or that are imaginary. Okay? And the last thing we're going to look at in this lesson is the density property, and that's basically the idea that if you have a number line and you have 2 numbers on it, there's always going to be a number in between those 2. Okay? And if I say, okay, well now these are my 2 numbers, well there's going to be a number between those 2. Well now these are my numbers, there's going to be a number between those 2. And on forever. Right? There's always going to be a number, no matter how small the numbers you try and get on that number line, there's always a number between them. Okay? All right, concept 1, classifying real numbers. So now we are taking numbers and we're having to put them into those categories. Okay, and we can look down at our little diagram here again. We're going to start by simplifying the number, because sometimes we get something that's still an expression. Okay, there's still a multiplication or an addition in there. The first step is to simplify it. All right, if it can't be represented as a fraction or a decimal that ends or repeats, excuse me, it's irrational. Okay, if you can't represent it as a decimal that ends or repeats, it's irrational. All right, I included fraction in here because we'll often see fractions, and sometimes it's hard to convert them. But even if it's a strange fraction, you should be able to turn it into either a decimal that ends or repeats. Okay, and if you can't, it's going to be irrational. All right, if it can be expressed as a decimal that ends or repeats, it's rational. And keep in mind that if it doesn't have a decimal, right, if it's just like 3, well, that does have a decimal. It's right there, and it ended. Okay, so it's rational. All right, if it's irrational, you're done. Okay, it's a real number, and it's irrational. If it's a rational number, you got to keep looking to figure out how many of these other categories it belongs in. Okay, if it is negative, it's going to be an integer, and it's not going to go any farther. Okay, if it's 0, it'll be an integer and a whole number, but it's not going to go any farther than that. If it is positive, all right, so it's not 0, it's not negative. If it's a positive number without a decimal, it's going to be a natural number. Okay, if we look at some examples here, 1.4, well, that has a decimal that ends. 2 times 1.3, well, this needs to be simplified. 2 times 1.3 is going to be 2.6, which has a decimal. The decimal ends, so it's going to be a rational number. Okay, square root of 24. If you put that on your calculator, it's going to give you a super long string of numbers, and it's going to basically go on forever, and it's not going to ever repeat. If you put a square root into your calculator and you get anything but a natural number, it's going to be an irrational number. Okay. All right. Negative 17. Well, it's a negative, so it's going to be an integer, but that's where it ends. 0. It's a whole number, it's an integer, it's a rational number, it's a real number, but it's not going to be a natural number. The square root of 25. Well, the square root is asking us what number times itself is going to equal to this is going to be equal to this number in here. 5 times 5 is equal to 25, so this is equal to 5, which makes this a natural number. Okay, 6 divided by 3, well, that's just equal to 2. That's another natural number. Okay, and when we're classifying these, we're going to have to list all the categories that it fits in. So this number is a natural, whole, integer, rational, and real number. All right, 2 and 5 are all 5 of those categories. Okay, 0 is all 4 of those categories. Okay, it's a whole number, it's an integer, a rational number, a real number. Okay, and the further you go out, the less you have to write. If it's an irrational number, it's just irrational, but it is a real number. Okay, pi is a real number, so it's irrational and real.